This video covers Section 8.5, Linear Functions and Models. Objective 2, find the zero of a linear function. Recall, if f of r equals 0 for some number r, then r is called a zero of f. To find the zero of any function, we solve the equation f of x equals 0. When we say f of r equals 0 for some number r, all we're saying is, what is the x value? That makes f of x equal to 0. This means we replace the f of x with 0 and solve for x. We subtract 18 from both sides. And have negative 18 equals negative 6x. Dividing both sides by negative 6 gives us x equal to 3. So we say 3 is the zero of f of x. This leads me to practice 3 for you to try. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. Two parts to this: graph the linear function and then find the zero of f of x. So the first part is to graph. We see that the slope is negative 3/4, and we see that the y-intercept is 0, 6. So we have a rise of negative 3 and a run of 4. Rise of negative 3 and a run of 1, 2, 3, 4. Rise 1, 2, 3, negative, and run 1, 2, 3, 4. Or we can rise positive 3 and run negative 4. And rise 1, 2, 3, 1, 2, 3, 4. And there's the graph. And now to find the zero, we go ahead and set f of x equal to 0. So doing that, we have f of x is negative 3/4 x plus 6. So setting f of x equal to 0 gives us 0 equals negative 3/4 x plus 6. We solve this equation by subtracting 6 from both sides. And now we solve this one by multiplying both sides by the reciprocal. This gives us x by itself. 3 goes into 3 once, into 6 twice, and we have negative 4 times negative 2 is 8. So 8 is the 0. And so we make this connection then that 8 is the 0, and from the graph, eight comma 0 is the x-intercept. So from the graph, you can see your 0. In this case, 8 being the 0. Example 3. Tony's weekly salary at Apple Chevrolet is 0.75% of his weekly sales plus $450. So the function s of x equals 0.0075x plus 450 describes Tony's weekly salary s as a linear function of his weekly sales x. What is the implied domain of the function? The domain is the set of x values that makes sense for us to put into the function. And if x represents his weekly sales, then it could be possible that the weekly sales are 0, could be possible that the weekly sales are 500. We would say that the weekly sales would need to be greater than or equal to 0. Wouldn't make sense to have negative sales. Letter B, if Tony sells cars worth a total of $50,000 one week, what is his salary? So he sells cars worth a total of $50,000 one week for his company. That means X is 50,000. His salary is S of 50,000. He's going to get 0.75% of that. And he makes this $450 regardless. So if he makes 0.75% of $50,000, we'll take the 4 decimal spaces away from the 0.0075, take 1, 2, 3, 4 decimals away. He's going to make 75 times 5, make $375 for this commission. Plus the $450 that he makes regardless, and that gives him $825 for his salary. Letter C, if Tony earned $600 one week, what was the value of the cars that he sold? Tony earns $600 one week. That is his salary. So this is setting S of X equal to 600 and find X, the value of all the cars that he sold. So we have 600 equals 0.0075 X plus 450. So we take that 450 away from the 600, and we see that he made $150 that week in commission. Divide both sides by 0.0075. And that says that the value of the car sold is 150 divided by 0.0075. Move the decimal 4 spaces over in the denominator, and move the decimal over 1, 2, 3, 4 in the numerator. 75 goes into 152 times. Remainder 0. And we add the remaining zeros. and we have $20,000. In sales that week. Letter D, draw a graph of the function. We know that the salary is 0.0075x plus 450. So that we know that if he doesn't sell anything, he's going to make $450 right off the start. We saw that $20,000 in sales gives us $600. And we saw that $50,000 gave us $825. So we have those 3 points. That's enough to graph this. And letter E, for what values of cars will Tony's weekly salary exceed $1,200? We see that for $50,000 in sales, his weekly salary was only $825. So we're going to have to sell more than $50,000 to exceed $1,200. So let's figure out what makes the sales, for what value of the sales makes the salary exceed $1,200. .0075x plus 450, we want that to exceed $1,200. Subtract 450 from both sides. $750 in commission. So we divide both sides by 0.0075. That says that x needs to be larger than 750 divided by 0.0075. Move the denominator's decimal over 4 spaces to the right, which gives us 75 into 750, 1, 2, 3, 4. 75 goes to 75 one time, 0, so we fill the rest in with zeros. So Tony needs to sell more than $100,000 worth of cars a week to make more than $1,200. So on the graph, that would have meant going out here another 50,000 to 100,000, and this line would have gone up to the $1,200 mark. This concludes the video for section 8.5, linear functions and models. Objective 2, find the zero of a linear function.